Okay, let's start adding and subtracting polynomials. So the first thing we need to do is talk about what is a polynomial. So a polynomial is an expression. So it's an expression as opposed to an equation that consists of terms summed together. Sum meaning add. And we always say add because we really add even if the numbers are negative, really, right? We always change everything to adding the opposite when we have subtraction. Each term must be a product, and product means multiply, of a number and one or more variables raised to whole number powers. Since 0 is a whole number, a term can just be a number. A polynomial must have one term. So what they mean by that is if I had 4 times x to the 0 power, that would be the same thing as, it would be actually 4. Yes, 4 times 1. So when you have just a constant number, you could say really you have a variable to the 0 power that's sort of implied. You would never see it, but they're saying that this would count as a term because it does have a variable to the 0 power, which is 1. That's going to be more important later when we get to degrees. We'll talk about that later. Okay. The coefficient is numerical coefficient of a term is the numerical factor of the term. So if I say 5x squared, the coefficient is the 5. When a term only has one variable, its degree is the exponent of that variable. When a term has more than one variable, its degree is the sum of the exponents of the variable of those terms. When the term has no variable, its degree is 0. Okay, so if I say 5x squared, the degree of that term is 2. What about 5x squared y? They're saying if it has more, if the term, this is a term, it's all multiplied, so it's one term. It's not, there's no adding going on. This one term has a degree of 3 because this has an exponent of 1, so they say the sum of the exponents. So 2 plus 1 is 3. This has a degree of 3. And then if there's just a number like up above, there's just the number 4, well, we can say there was x to the 0 power. So just the number 4 has, with no, when you see no variable next to it, it has a degree of 0, right? Because this one has a degree of, just this variable here has a degree of 1. So because we don't see it, there's an x to the 0 power. That's why the degree here is 0. Because x to the 0 power is 1. Right? So we're using the exponent on the variable to determine the degree. Okay. The degree of a polynomial is the greatest degree that appears amongst the terms. So if I have multiple terms, right? Let's say I have 2x to the third plus 3x squared plus x plus 4. Okay, what we call that is standard form because I've written them in order. This term right here has a degree of 3. This term right here has a degree of, this term right here has a degree of 1, right? This term right here has a degree of 0. So they're stacked in order, aren't they? I always want to put them in order, the biggest to the smallest. It's not bad, it's not wrong if I don't, but that's standard form. Standard form is put the big guy first. Then we say, okay, the big guy, the leader of the pack, decides the degree for the whole polynomial. Because the word polynomial means many terms. So I have 1 term, 2 terms, 3 terms, 4 terms. We don't have a word for that. 1 term is monomial. 2 terms is binomial. 3 terms is trinomial. 4 terms we just say polynomial. After 3 we stop counting. You don't ever hear anyone talk about quadnomial. What does that even mean? Okay, but the big guy decides the degree for the whole polynomial. Since we're all being added together, and I can't add them together because they're not like terms, the whole entire thing has a degree. The whole polynomial has a degree of 3. So everything that we were graphing before was linear. You remember y equals mx plus b? Everything that was, we called those first degree polynomials, really. If we're gonna get into quadratics, which are actually have an exponent of 2, so we would call those all second degree. This whole polynomial here is all third degree because I say for all of us, we're all being added together. I decide, I'm the big guy, okay? A polynomial with one term is called a monomial, so that's what we were just talking about, monomial. Polynomial with 2 terms is called a binomial. Polynomial with 3 terms is called a trinomial. So 1, 2, 3, right? Okay, so list some examples of expressions that are polynomials and examples of expressions that are not polynomials. So polynomials, what they have to have is they have to have whole number exponents. Where did I see that above? Well, anyway, I wanted to underline it. So 5 could be considered a polynomial because 5 is technically next to x to the 0, right? So we say this one has a degree of 1. And since it's only degree of 0, sorry. Since it's only one term, it's considered a monomial, right? Poly just means many. If I get more specific and I only have one, right, then I call it a monomial. An example of a binomial could be x plus 5, right? X plus 5 is a binomial. X is to the first power, so the degree is 1. Now, that might be where I'm getting some confused looks because there's the degree of the terms. These are 2 terms, right? So this degree is 1, this degree is 0, and then there's the degree of the polynomial, which is like add the 2 things together, just whatever the degree of the big guy is decides, okay? Okay, let's do an example of a trinomial. X squared plus 6x plus 9 would be an example of a trinomial. Is a trinomial, okay? And its degree is what? Degree is 2. That's because this has a degree of 2, this has a degree of 1. The constant always has a degree of 0. You see no variable there? You're like, there's 0 variables. Okay, great. It has a degree of 0 then if there's no variables. Okay, so some examples. So these are all polynomials. These all are polynomials. Okay? Some non-polynomials. X to the negative 3 power is considered not a polynomial. Why isn't it a polynomial? Well, it doesn't have the exponent is not a whole number. What kind of number is negative 3? It's an integer. Good recalling that. Yes, it's an integer. So just the fact, I mean, it doesn't mean that it's not important, x to the negative 3 power. It's just not a polynomial. It doesn't fall into our definition, okay? Also, something like this, the square root of x would be not a polynomial. And that's actually because some of you might remember this from last term. Did we talk about what kind of exponent the square root of x has? The square root of x, okay, this is going to be some advanced math. I'm not going to go down this whole rabbit hole, but take my word for it, it's to the 1/2 power. And a fraction, is a fraction a whole number? No. A fraction is not a whole number. I should say right here, an integer, because that's an integer. Integers are not whole. Well, negative integers. Actually, positive integers are whole, aren't they? Okay, but proper fractions cannot be whole numbers, right? Any proper fraction? Okay, good. Trying to think of some other examples. What about this one? The cube root of x. Because you might be thinking, well, that looks like x to the first power, but really the cube root of x is, again, it has a fraction exponent. So proper fractions are not whole numbers. Okay, that's all I can think of for now, but you'll go back and look at the completed notes. There's some other examples there too. So you don't want to see x's in the denominator because that would make it not whole because it has a negative number. And you don't want to see fraction exponents. So that is basically where we get that from, the square root and the cube root. But again, we'll get back to that. We'll come back to that sometime. Probably Math 95. Just you'll remember. You'll be like, oh yeah, she's talking about fraction exponents. Just make sure that your exponents are whole numbers. Okay, so for this polynomial, we want to first put it in standard form. So the thing is that when we put it in standard form, we're going to put it in order of degree. So standard form for this one is going to be what would come first. So the biggest degree has to come first. What's that one? 5.6x squared is the biggest, has the biggest degree, that term, right? Then followed by, well, the 1.4 doesn't even have a variable, so we know its degree is 0. What's the degree of negative 3.5x? 1. So negative 3.5x comes next, plus 1.4 is the constant. So when we put it in standard form, in order of degree, okay, then we have a leading term. The leading term is the very beginning one. Once you put it in order, then you can tell us what the leading term is. So what is the leading term? Yeah, and the degree is 2. Good. Degree, I heard 2. Degree of 2. What's the degree of the whole entire polynomial, meaning all 3 terms? Yeah, it's 2. Degree of 2, because the leading term decides the degree. What are the terms in the polynomial? Meaning, how many terms do we have and what are they individually? We have 3 terms, and 3 terms makes it a trinomial. And the terms we'll just write out as 5.6x squared, comma, instead of plus, negative 3.5x is a term, and 1.4 is a term. So those are all 3 terms. What are the degrees of each of the terms? So the degree of this one is 2. The degree of this one is 1. And the degree of this one, the constant, is 0. Okay, I should circle the 0, but that's going to look like a donut now. Okay, whatever. I had a pattern. I was circling them. It would just look weird if I didn't keep circling them. How many terms does this polynomial have? Oh, we already answered that question. We said 3. That makes it a trinomial. Okay. Let's try it when we have, let's do this one together since there's multiple variables going on. Okay, this is a hard question right now, but is this technically in standard form? Yes, it is. Because what's the degree of this one? 4. Degree of 4. And this one is a degree of what? degree of 3. So the leading term is, yes. What is the degree of the polynomial? It's actually just 4, because this is the leading term. The leading term has the biggest degree and decides the degree for the whole polynomial. So it doesn't actually matter what gets added to that first term. The first term says, I don't care, you guys are all so insignificant compared to me. I am the leader of the pack, and I decide we are all going to be degree 4. It's that dramatic, right? So it's like, I don't care about you. You're very insignificant to me. What are the terms of the polynomial? Yes?
X and Y are like terms?
They're not. They're one term. They're all multiplied.
Oh.
So when you have one term, there's all multiplication in between. Yeah. And the reason why we can't subtract those from each other is they're not alike. They're not like terms. We're going to get to that.
It's still 4 even though...
Yes, because what we do is when we have multiple variables, we add the exponents of when they're multiplied in one term. Okay? So what are the terms of the polynomial? The terms would be 8x squared y squared is one term. The second term is negative 2x to the third. What is the degree of each term? The degree of the first term is 4. The degree of the second term is 3. That's how we know we have it in order. How many terms does this polynomial have? 2. 2 terms. And the reason why it has 2 terms is because this is a product subtracted from this product. Basically, all add and subtract separate terms. Okay? And if they're alike, of course, we would add them together. So since this has 2 terms, we call it a binomial. Okay. Questions about that? At some point, yes. Okay, I want you guys to try group work 1 and 2.